guys, welcome back. This is Daniel Pinheiro from danielpm1982.com. Okay, now we're gonna see three very important subjects for any developer, which are how to create tests, and for that we're gonna use JUnit 5 framework, and actually we have to import that dependency or ask IntelliJ to import that for us. We're not using Maven, so we can't include that as a POM dependency for now, but I'll tell you where in IntelliJ to import, and IntelliJ will add that imported JUnit 5 to the external libs of our project, as you can see here. So we have basically in this project two main dependencies, which are the JDK 14, which is automatically added here at the project when we select which JDK we want to use when creating the new project, and we'll have also the JUnit 5 added here. I'll actually delete this one for showing you how to add it. So if you go here at File, Project Structure, and go here to Modules, we have only one module which our project is based on. And if you go here to, for this only module, you have the sources, which is basically the project structure. You have the paths, and you have the project dependencies. And I had previously tested adding JUnit for creating the test class, so it's already added here, but I can remove it for then tell you how to add it. So now the project has only JDK 14 as a dependency, and I'll show you how to add the JUnit 5 dependency. But before that, let me just show you some changes that I've done on the project we had so far. So the domain classes are still the same. I have not yet done any upgrade on them. We'll do when we start using JPA, because we're gonna annotate them with JPA annotations. But I have changed the main class, and I also have added a helper folder just for simulating here one class for the database. We have not yet implemented a real database. We'll do that in the next example or on the next upgrade of this Java application we are developing. So first let me show you here the DB class we have, which is very simple and basically are some static lists simulating the tables we're gonna have at the real database we're gonna implement. Here down below, instead of a constructor, we have a static initializer for initializing these four lists and instantiate them when the DB class is called for the first time. So anywhere on the code where the DB is used, the first thing it's going to do is statically initialize these four lists and point these static references to empty array lists, as here you can see. And down below here we have simply the get accessor methods for the client list, the order list, the order item list, and the product list. So this will basically simulate a real database, but of course we will not need this class starting from the next version of our project, because we'll implement the real database, and this class will not be needed anymore. So I've just created as a simulation, and for accessing that database or DB class, we are gonna use this DAO class, which is also a simulation of what a real DAO would be. In a DAO, you would have CRUD methods for accessing your database, as well as a connection to it implemented. And the connection in this case is basically the references for the lists of that DB class. So here, let me maximize here. That reference would be also some static local lists or local static fields, and through a static initializer, I simply point out those static fields to the DB respective list. So for example, for this local DAO client list, I'll point this reference to the DB client list by using the static get client list from the DB class, as well as for the product list, the order list, and the order item list. So I'm not creating any new list or instantiating any new list. I simply point a local DAO static reference to the already existing lists at the DB class. So this simulates the connection we would have to a real database, because through these local static variables now we have access to all 4 tables or lists from the DB class. And if for any reason any of these 4 variables end up pointing out to a null, then we throw here a runtime exception telling that an error has occurred while initializing the database, or that no database source is available, or specifically that the DAO class, which is this one, can't communicate with the database source. The database source in this case being the DB class and its lists. So this simulates our connection to the database, and down here I simply implement 2 CRUD methods for that simulated connection. One is the persist and the other is the retrieve one. And also I'll implement here a helper method just for showing if the persisting element already exists or not at those DB lists we are pointing out from our local references here. So these DAO methods, of course they are not CRUD methods of a real DAO because we have not the connection yet, but just simulating that here. For example, the persist object we accept from any package an object, and that object can be a client or a product or an order or another item. I just use the object general parameter here to accept all 4 types without having to write 4 different methods into the same DAO, because in practice when we start creating our MVC applications, or even starting from the next update for this application, we will actually create one DAO for every table or for every domain class. So we will have a DAO for client and another DAO for product, another one for order, and a 4th one for order item, and then we'll use them from inside an interface that the controller will use. So as we have the 4 references here for the 4 lists inside one same DAO, I would have to offer CRUD methods for adding and for retrieving all 4 types of objects, either client or product or other item, and for putting that into one same method I used the object for accepting whatever object the calling class would send as argument. But here, before persisting the object that the calling class will send, I first check if that object already exists or not. That's why I created this other method here, does exist, which returns true if the object is already at the lists. So if the object does not exist on its respective list, then here at the persist object method I'll check the instance of that object being received as argument, and if it's a client object I'll add it to the client list. If it's a product, I'll add it to the product list. If it's an order, to the order list, and if it's another item, to the other item list. But only in case it doesn't exist yet inside its respective list. If it already exists inside its list, for example, if the argument is a client object, I'll check if that already exists at the client list. If it doesn't exist, I'll add it here. But if it already exists, I won't add that argument object. I'll simply return the already existing object at its respective list by retrieving it from the primary key of that object. So if it's a client object and if it already exists, I'll not add it, and I'll simply retrieve the existing version of it at the list, and I'll send back as a return for this persisting object method. But if it doesn't exist, I'll add it, and I also return the added object. So if I'm persisting a client object, I'll receive it because it's also an object, so I can receive any derived object from object, and client is one of them, and client, as all other objects, is derived from object, so it will accept a client object here. And I'll check if the client doesn't exist at the client list. If it doesn't, then I'll add that client to the DB client list. If that client already exists, then I'll simply use the ID of that client, which is the primary key for the respective table, to retrieve the already existing object or data for that client. And in both cases, I'll return either the added client or the already existing one as a result for this persist object method. So this is the first method of this simulated DAO. The other main method we have here at the DAO is the retrieve method. And as with the persist object method, I've also used a general parameter type here, object, to receive any of the 4 domain entity types. So for example, if the retrieve object method receives a client argument here, it will identify that that object is an instance of client, and it will search at the DB client list by getting a stream of all the clients of that list, and it will filter all the elements whose ID matches the ID of the received client, and it will find one and only instance of client. Of course, we'll have only one instance for that ID. The ID is the primary key. We can't have more than one instance for the same primary key. And when getting that one and only instance of client, it will return that, or if it doesn't find, it will return no. So if we receive instead of client a product argument, it's the same process. You search at the product list by using string and the filter operator for an element whose ID matches that product argument ID. We'll get the one and only element, and we return that element from this method, or else if it's not found, we return no. And the same for other and for other item, by using in this case the other list and the other item list respectively. And if the receiving object argument is none of these instance types, it simply returns no. And the does exist method is very simple. It simply receives an object that can be of any of the four types, either client or product or other item, and it calls the retrieve object method to test if that argument object exists on the respective list here, and returns true if there's an element returning, or returns false if the returning is no, which means that no object has been found at the lists for that argument. So in the case that argument object exists in the respective list and the argument is different to null, will be true, but if the element does not exist on the respective list, the retrieve object will retrieve null, and this comparison here will be false, so the element does not exist. And this does exist method I use here at the persist object to first check if the persisting element already exists or not, for only adding at the list if it really does not exist. If it does exist in the respective list, then I simply return the existing data for the already existing object. And regarding the visibility, the only public method here is the persist object. The does exist and the retrieve object we are not setting as public. Will only be used both here at the persist object by calling this does exist and it does exist calling the retrieve one. So the only thing this DAO will offer as a CRUD method for outside is the persistence for any of the four types of objects, and one last method here, which is a get other item list, also public, and that we can call from outside to get the DB other item list. Actually, in a real project, we would not send back the actual reference, but an immutable copy of that list that would not be changeable, or if it was changed, it would not affect the real database list. But as it's a simple project, I'll return the reference itself for the DB other item list. So this is our DAO that simply offers a persist method and a get other item list method for any class or instance of a class inside the same package, because if you see here, I'm using the package visibility for the class, both for the DAO as for the DB. So neither the DB nor the DAO will be visible from outside this helper package, because the only class I want to be called from outside this folder or this package is the populate helper. So if you go here to the populate helper, this populate helper will call the two public methods from the DAO, which is the persist and the get other item list, and the DAO then will call the DB. But from outside this helper package, we'll only be able to call the populate helper static methods. So let's see this populate helper, which will be called by the main class. So this populate helper class will be a public one, and it will be visible from outside this package, and it will have also two public static methods, which are the populate sample data, which will populate the DB for all the object types, the client, the products, the order, and the other items. And the other public one is this get order item list, which is basically the same get order item list from the DAO, but in this case it's accessible from outside the package, because the scope of this class now is public and not packaged differently from the DAO and DB. So the main method at the main class will be able to call this class and basically call two methods, the populate sample data and the get order item list, which actually will not be called by the main class but from the main class tester class. So let's see here the populate sample data. It's a public static method that returns a list of other items, but before returning that list, it first creates all those instances we had created at the main. Instead of creating there, we are now creating here at the populate helper class and inside this populate sample data. And then this method will be called at the main method at the main class. And after creating and adding all these instances to the respective lists at the DB class, it returns a list of other items with all these created other items, with all the orders, with all the products, and for all the clients. In this case, we have here 4 clients. So for 4 clients, we create the order and the other items, and we'll return a list with all the other items for all the clients. Just have in mind here that we are not returning any of the lists from the database. Here we are creating and returning a list with the instances just created for each calling of this populate sample data. So if you call it 5 times, the returning list will not be the whole database state. It will be only the created and just added other items from the current method call. So we could have, for example, 1,000 instances at the database for this list order item, but for one single call of this populate sample data, it would return only a list with, in this case, 7 items, which would have been the items just created at that current call. So this distinction is important to know, and I've actually explained it here at this comment. You can read it later. It's important for our test class, because at the test class we compare the list received at the main method, at the main class, which will be this one, with only these 7 instances for the latest call of the populate sample data, with the state or with the list or the item list from the DB to check if the number, sequence, and equality of the other item instances are the same, both at the main, which receives this list here, as directly by getting the other item list from the database through this populate helper method down here below. So at the test class that I'll still show you how to create, we'll have an expected list, which will be get directly from the database through this get other item list, which is public and can be called directly from the helper class, and compare that expected list with this actual list that the main method at the main class will receive and calling the populate sample data. And at the test class I'll show you why I'll do that comparison. But I'm just advancing a little bit to show you that there's a difference between the list that the populate sample data returns and the list that we get directly from the DB or the DAO as the whole state for the other item list. They may be the same or they may be different. And then, as you see here, I'm not instantiating directly any of these objects. For example, for the client object, instead of instantiating here directly, I'm calling the create and add client method, which is down here. It's a private method, so it can't be called from outside, but I've separated here only for organizing the code, because for each of the types, for example for the client, as for the product, for the order, and for the order item, we have 4 different creating processes. For the client, for example, when creating the client, I'll call this create and add client, which is down here, create and add client, passing all the parameters we would pass to instantiate it according to the parameters of the complete constructor of that object type. So here is the instantiation of the client using the full constructor and passing these arguments received at the create and add client to the constructor of the client and pointing that through this local temp variable. And after instantiating the client, I then use the persist object method from the DAO class, a static method for trying to persist that instance that I've just created. It can persist, or if it already exists, it will simply retrieve the existing data for that same ID. And the static persist object from the DAO will return an object type that I identify here as a persisted object, and then I confirm that that persistent object is of type client, and then I return that downcasted persisted object as a client object to the calling method, which is the populate sample data. So this create and add client will simply create and persist a client and return a client instance to this C1 client local variable. And the same for the product. If you see here down below, we have the create and add product. The same for the order. Here we have the create and add order, and the same for the order item creation. If you see here, we also have a create and add order item method that will instantiate that object type. It will try to persist it through the DAO, receiving the persisted or eventually the already existing order item as an object type. Then I check if that object type is actually another item type and return that as the created and persisted or retrieved object to the calling statement here, associating that to a local variable. And at the end, I take all those local variables with the created and persisted client, product, order, and order types, and return to the calling class or the calling method as a list of order items with all the created order items here. And through the order items you can get all the other objects also created and persisted or eventually simply retrieved if already existing at the DB lists. So this is the populated helper, and we will use it basically from the main method by calling this public populate sample data. Instead of instantiating and trying to persist all of this from inside the main method, we'll simply use this helper method and populate sample data method to do all this job from here. And the other public method, the get order item list, we will use to get the order item list directly from the DAO and from the DAO directly from the database, and compare that with the list that main method receives from this populate sample data here. So this is the populate helper class. And now we've seen all the three classes that I've added at the helper package. And now let's see the changes that I've made at the main class. And we've actually simplified a lot our main class. So here at the main method, at the main class, we simply show some information for the final user. For example, the hello value here that we extracted to a static constant using IntelliJ. Then we show an information that we're gonna populate data at the database, and we call this populate sample data, which is a local method here, populate sample data. And this will call in turn the populate sample data method at the populate helper class. And at the populate helper class, this populate sample data method will create, as we saw, all the instances and try to persist them at the database lists and return for the calling method or class, which in this case is the main class, a list of type order item with all the order item lists created at that single call for this populate sample data method at the populate helper class. So this order item list here, initially it's null, but when we call here the local populate sample data, that populate sample data will call the populate sample data at the populate helper class, and it will return the created and persisted order item instances as an order item list and associate that to this static field order item list. And then after populating, we confirm that the database has been populated and also the number of order items created. which in this case are 7. And next we call this print data local method, which will print the data for all the clients with orders, because it will always get the other instances from the order item list. So from the order item list, it will show all the orders and products and the clients that are related to at least one order. Because if the client doesn't have any order, it won't be reachable from the order item list instances. But if it has, then from the item list we can get the order, and from the order we can get the respective client. So it will just print all that data from the order item list. In here it will do the same, but separating the data per client. For example, it will show all the data for the client 1, then it will show all the data for the client 2, and so on. But also if those clients have a relationship with at least one order instance. If not, the client also won't be reachable. Okay, so this is the main method from the main class. And after I think a lot about what I would test here, because we have a too simple project. We have not any real state change to be tested at the testing classes. I decided to simply test this populate sample data and check if this resulting order item list that returns from the populate sample data from the populate helper class here, if it has the same state or the same elements and sequence and the same equality of elements as the order item list directly from the database. So that's basically what we're gonna test. First, we'll check if this order item list is initially null. Then after populating, we'll check if the order item list is different from null, because it would already have received the order item list from the populate sample data method from the populate helper class after the populate sample data is called. So it wouldn't be null anymore, it would be different from null. And the third thing that we're gonna test is if this returning item list is exactly the same as the order item list when got directly from the database. So the database state would have to be consistent with this list here, and actually it should be equal, because both for the database as for this population method call, we would start with empty lists. So after adding all the sample instances at the database, this resulting order item list should be exactly the same as the list at the database. And also I'll leverage on that to also test if the constraint that I've implemented at the DAO for the persist method is functioning for guaranteeing the key integrity constraint of the database, because we won't be able, even if we run this method many times, we should not have more than one instance with the same primary key. So when this populate sample data from the populate helper class is called many times, actually none of the elements created should be persisted more than once at the database. So if that constraint control works, then we would keep exactly the same elements at the database compared to this order item list here after each populate sample data call. Otherwise, if our key integrity constraint control is not working at the JAO class or at the persist object method there, then every time that I call this populate sample data at the populate helper class, it will create new instances and will successfully persist every one of them multiple times at the database list, and we would end up with a much different order list at the database with much more elements when compared to this order item list here for each and current populate sample data calling. So more synthetically, the third thing we're gonna test regarding this main class is if this returning order item list is exactly equal to the database order item list, and that will confirm the integrity of our database, specifically regarding the key integrity constraint. So we are testing the main class because we are calling this method from the main class, but we are also testing the persist object control or constraint at the JAO called by this populate sample data method from the populate helper class. You can later see all this code from my GitHub repository. We're gonna integrate Git and I'll push this version 1 Java application to my profile public repository so that you can check there this whole code, the domain classes which we haven't changed, and also you can check this new helper package here with these temporary classes which we're gonna change on the next version of this application, because the DB here will evolve to a real MySQL database, the GAO here will evolve to a real CRUD GAO using JDBC, and we'll divide this generic GAO for a specific GAO for each of the domain classes. One GAO for client, one GAO for order, one GAO for order item, and one for product. And then I'll create another class for managing all those GAOs when any controller class wants to manage one or more of these domain objects or respective database tables. So it will change a lot, this helper package as well. And the main class that we have here will be changed to a controller class. And on the next example, still without a web view, but on the later examples, we'll also add a web HTML view with CSS and Timeleaf for separating the view from the controller. So at the controller, we'll call the class that will deal with the GAOs we're going to create, and that will be connected to the real database. And maybe from the controller, we will call a helper class to create a batch of instances for testing all the project flux. So everything will change on the next update except the domain classes again. Okay, now having explained all those alterations that I had to do to the original initial project, now we're gonna create our JUnit 5 testing class for the main class. We are not testing the other classes because all of them will change a lot and they are merely simulations to what we're really gonna do. So I'll just test this main class as I've said before, and for that I have also created a new folder or package called test inside which we should put all the testing classes, and in this case we are gonna have only one testing class for the one and only main class. So if you go to the main class, let me maximize here. As you know, we have 3 methods, but these 2 printing methods, there's nothing to test from them. So we'll simply test this populate sample data from the main class. And for that, you can simply go here to the method, click the right button, generate, or you could also use the shortcut Alt Insert, generate test. And then you select here whatever JUnit version you want, or Groovy, or Spock, but I will use JUnit 5. And as I told you before, it will say that JUnit 5 library is not available, so you will have to fix it by clicking here. And by clicking here, it will automatically download all the dependencies for the JUnit 5. Even in this project we are not using Maven, IntelliJ will be able to download this external dependency and automatically add that to the class path or to the module of our project, simply clicking here, fix. So let's click it. Here is the dependency name. You simply press OK. If you just cancel here, let's just see that the dependency has been added. Here it is, all the jars or dependencies for the JUnit platform engine and commons, as well as for the JUnit Jupyter extending API. So as you know, or in case you don't, JUnit 5 is not a monolithic API or engine as JUnit 4 was. Its architecture is basically composed by a base engine or core code, and to that there can be many extensions or extending APIs, and the basic API that extends that platform and that you will as a programmer deal with when developing any product with JUnit 5 is the JUnit 5 Jupyter. So all of the annotations we'll use are from JUnit Jupyter API, which then connects to the JUnit central or core platform for making the whole framework work. So basically, here are the 2 external libraries we have. The JDK 14 libraries with all Java Core SE GREs and classes. And now we have another dependency added to the class path of the application, which are the JUnit 5.4 dependency. So you can see it here at the external libraries at your project structure, or you can also go here to File, Project Structure, go to the modules. At the modules, you go to Dependencies, and now you have here the 2 dependencies. We have the JDK 14 and the JUnit 5.4 dependency. So we can simply now use any JUnit 5 and JUnit 5 Jupyter annotation to create our testing classes. So let's go back to the main and to the main method we want to test, which is this single method populate sample data, and we'll go again to the generate test. Now as you can see, it already recognized that we have the JUnit 5 dependencies installed, so it won't show the fix message again unless we delete that dependency from our project. Here it's the class name for the test class. We'll simply call main test. The destination package, it's con.danielpm1982.test. It's the package test that I've already created, at the base package con.danielpimenta82, and here you can select if you want to generate a setup and teardown for at before and at after. In here you select the methods that you want to create the tests for. So we are testing the main class. If we had many methods, many public methods that we wanted to test, the method got to be public for this to work. If we want to test many public methods from the main class in this case, then we would select all the methods we wanted, but in this case we test only one single method, so we just select this populate sample data method, and then we click OK, and here we have the base template for a testing class for the main class, and specifically for the populate sample data method from the main class. But instead of writing all the testing class, let me just copy and paste a class that I have already created. So here it is, all the testing class that I have designed for that main class populating method. As you see, it's quite big, so I won't type everything on this video, but you can then check the code at the GitHub repository. Okay, and as you can see here, it's not actually recognizing the JUnit 5 Jupyter packages for the annotations we're using. Basically because if you go here at the file, project structure, and go to the module, and go to dependencies, and for JUnit 5, which is the dependency that IntelliJ has automatically added, the scope for that dependency is exclusively for tests. So that dependency will not be available for the compile time or for the runtime, only for the test time. And to correct that and turn that dependencies available at compile time, you just change here the scope to, instead of test, to compile. Click OK, and that should solve that problem. So now all JUnit 5 dependencies are also available at compile time. Okay, so this is the main class test class, and here I'll not explain everything about JUnit 5 or JUnit 5 annotations, but here at the main test class we have the display name, which is the name that will appear when we test. You see the hierarchy of the testing components, and the class components will be called main class test, as well as each method we have. And for example, here we have a before all method with this display setup main class test, which will run actually before the main test is instantiated by the JUnit 5 engine. So that's why we have to put it as static, both the before all method as the after all method. They must be static because they will be called even before this main test class is instantiated. So the only way to let JUnit call them is to make them static. So this is the before all, which simply inject these two JUnit 5 objects here inside the test info, which has some information about the method name and so on, and the test reporter, which will be our output object to show these messages at the console. So here we inject the test info and we show it here, and we also inject the test reporter object, and for that we also point that instance from a static field test reporter for reusing that on the other methods without injecting it again. So we are injecting only one time here, and we'll point in it from this static field test reporter. So every time we want to show a message, we'll reuse this field to point out to this injected object test reporter. After the before all, we have two nested classes. One for the successful cases, which is this one. We're putting all the successful cases for the populate data method inside this nested successful tests class inside the main test class. So the main test is the outer class, and the successful tests here is a nested inner class, as well as this other class failed tests for all the tests that should fail. So regarding this testing method from the main class, we are creating both testings for it not to fail, that it should complete successful if the code is right, and we are also creating some tests intentionally for it to fail, simulating some mistakes that we could make at the main class, but instead we are making those mistakes here so that we can check that the fail actually happens if those mistakes are done. Here below we have the after all, and now let's see the nested classes. First, the successful tests nested class, which is for the populate data method test, but for the successful tests, or for the successful cases, or for the happy cases, if you will. And for this nested inner successful tests, we have a before each method that will run before each test happens. In this case, we have only one actual test happening, or one actual test method, which is this populate data successful test. But if we had more than one test, this before each would run before each one of those tests. But in this case we have only one, and before this one, the before each will also run as well, and it will mainly show some information about the test, and it will set the main order item list static reference to null, because it's the original state of that list at the main class before the population occurs. So as we test the populate method, before each time this method runs, we should set the main order item list to null. So this is the before each method, and this is the after each method, which will run after each test method runs. And I repeat, in this case we have only one test method, but in case we had many, it would run also after each one of them. And one another annotation we're using is the @repeated test, which will be used to make this test method run not one but 5 times. So we'll test the populate method by calling it 5 times, one after another, to see if any inconsistency appears, either at the main class or specifically at the main order item list, which is the actual list, or at the DB direct list, which is the expected list. So we expect that the expected list, which is the DB order item list, is exactly the same as the actual list, which is the list at the main class, even after we call the populate method from the main class many times. So if we reach an equality both for the main order item list as for the DB direct order item list, it means two things. One is that the main class order item list is consistent with the list at the database and has not been degraded to any eventual inconsistency at the main class itself. And also it proves that our DAO persist method also guaranteed that each instance would be persisted only once at the DB lists. Otherwise, it would have many more instances than the instances returned from each populate method call. So these two lists must be exactly the same in terms of sequence of items, in terms of the number of those items inside the list, and also in terms of the equality of those items. In this case, the item is the other item instance that will be compared between the two lists. So if that passes, and we can assert that these two iterables are equal, then this test will pass, considering that it also passes the other two conditions here. One is the assert null for the initial order item list. So the order item list must be initially null. Then after the main class calls the populate sample data method, this should populate the database and return a list, and that list will be set to the order item list at the main class. So now we must assert that that same order item list is not null anymore, because it has already received the resulting order item list from the helper method that has created and persisted all the instances to the database and returned the list, which is set to this order item list from the main. So it must not be null anymore. And then, as I've said, after checking it's initially null and then not null anymore, you then check if the expected list directly at the database and the actual list, which is the one that returns after each running of this method, are exactly the same. So if the three conditions happen, then the test of this nested successful test class will pass. And at the before each and the after each of the tests, in this case only one, but it will run 5 times. So for each time it runs, we get simply a description about the initialization of the test and then about the ending of that test or of that repetition for that test. So this is the successful tests nested inner class. And now let's see here the other nested class, which is the failed tests class, into which I have checked exactly the same 3 conditions. First, if the order item list is initially null, then after calling the main populate sample data method, if the order list now is not null anymore, because it will have received the result list. And lastly, the third condition, which is if the expected list from the database directly and the actual list from the main are exactly the same. But in this case, with the populate data failed test, I have added here some add-ins to the code. For example, if you uncomment this line here and run the test, you see that this line will instantiate an array list and associate that instance with this static field from the main. So this list static field won't be null anymore, and the first condition for the test will fail. So if you uncomment this line, we will get a failure to this whole test of the method. And basically that's to prove that the method can actually fail at this testing class if for any reason at the main class we do this mistake of for any reason have the initial order item list pointing out to any reference and not to null. So just comment again. For comment you use Ctrl// and for uncomment you use the same shortcut and it uncomments the whole line. Or if you select more than one line, it will comment all those lines and uncomment them as well if you use again Ctrl/. So this is the first condition. Now the second condition, the way we have to make it fail if you uncomment this line is by setting null to the order item list of the main after the populate method is called, because in this case the order item list shouldn't be null and it will fail here on the assertion done here below because it will have this unexpected value null. So instead of asserting not equals to null, it will be equal to null, and thus this test will fail. But I'll also leave it commented, both this first one and this other one. And now the third condition, the way we have to make it fail, or the way we have to make these two lists differ from each other, is to, for example, creating another list with the same content of the order item list from the main, and for example removing the first element so that now the main order item list, which is the actual list, will have one element less. Specifically, the first element won't exist anymore. So when these two lists, the expected one, which is the one got directly from the database, and this actual one, which is the one from the main class, are compared, JUnit will detect that they are different, and not only that they are different, but it will also show at the error message or at the exception in what they are different. So it will basically compare all the indexes of those two lists, and it will detect that the element on the index 0 at the order item list actual will not exist or will be different now from the one at index 0 at the expected list. So as the lists are different, the test, this whole test, because of this third condition, will fail. So for the whole class test to pass, we can leave these lines commented, this one, and these two, and that way this test will be exactly the same as the happy test here, because we won't have provoked any failing and it will pass, or despite what we commented or not, we could simply let this populate data failed test method disabled through this @disabled annotation. But firstly, I'll leave this @disabled commented, so you can see that if we do not uncomment any of these lines, this failed test method will also pass as the successful test method will do. And also similar here, we have a before each and after each for each test method here at this failed test nested inner class. And also in this case we have only one, but in case we had more than one tests, before and after each one of them, these methods before each and after each would run for them independently. And another difference for this failed test compared to the successful test is that the successful test we use a repeated test annotation with a 5 repetition value, but for this other test, the failed test, we only run it once, so we use the @test annotation instead. So those are the happy path tests and the failed test. So now we have to run the main test class by simply clicking here, run main test. If we were to debug it, we would select this other one. I'll show you next how to debug classes. So now you simply use this run action here for the class or for specifically each one of the testing cases, or in this case for the inner classes, or for the testing methods. But instead of selecting only parts of this class to run, let's run the whole class, and all the inside testing methods will run as well. So run main test, it will run, and here it will show the results, and it actually creates a whole hierarchy here based on the display names that we've set. For example, here test results, main class test, and here it has run firstly the failed test nested inner class, and inside that it has run the populate data failed test method with no repetitions. This is the display name that we have put for it, and actually we can't control the order of the executing of each of the tests, although there is some syntax that you may try, but it generally doesn't work, and it ends up to be a randomly execution. And here it has run the other inner class, the successful tests class, with here the successful test with all 5 repetitions, repetition 1 of 5, repetition 2, 3, 4 and 5. And as you can see, it has passed everything. Let's just check to uncomment, for example, the third condition here, so that it will fail here at the comparison between the actual and the expected other item lists. And we now can run only this failed test method here, and as you can see, it has failed that test, and it also shows why here iterable contents differ at index 0. Why? Because we have deleted the first item of the actual list, and when it compares to the expected list, it will see that the first item of both are now different. If we comment again these 2 lines, /, then, and if we run again the test, it will now pass. So if you want to see more carefully the code here at the test class, you can also, as I've said, go to this version 1 project at my repository and check that there, or even clone the whole project and check that at your machine. So this is the main test class here at the test package. So for testing, it's basically this. If you wanna learn more about JUnit 5, you can go to the JUnit 5 page, which is this URL here, junit.org/JUnit5, and here you can see all the sponsors, including IntelliJ or JetBrains. And here you have a Java doc. Java doc is what the IDE would use to show you there when using the methods or the annotations. You have a question and answer section. You can support JUnit by donating. And you have this user guide, which is pretty easy to read, and it actually explains everything about JUnit 5 and even how to migrate from JUnit 4 to JUnit 5, how to integrate JUnit to all the main IDEs, including IntelliJ IDEA or Eclipse or NetBeans or Visual Studio Code and other IDEs. It also shows how to use Maven to run the tests. It talks about the extension models, advanced topics, evolution of this API, and this is a nice and easy to read. Even you can download here the PDF for the whole documentation. So if you wanna know more about JUnit 5, you just download this PDF user guide from junit.org/JUnit5. So let's go back. And now, before we start with our next subject, which is how to debug using IntelliJ, I would just like to show you 2 other actions that you can use to increase your productivity when using IntelliJ. For example, here, if we have any class opened and then we open another one, as you know, we can maximize here the editor section, but instead of having one class for the whole editor, we can divide either vertically or horizontally the screen for showing both classes, for example, by just pressing over the tab here, split, let's split vertically. So it will open this tab on which you clicked the right button. You can actually close this one on the other side of the divided screen. And it's actually pretty useful when you want to compare two different classes or two similar classes to see any difference between them. So you can divide it vertically or you can divide horizontally. So here you have you can close this one. So here you have the client class and here you have the other class. And the other thing is about one thing that I have already showed you, but I forgot to show you the shortcut, and you kind of have to use that shortcut because it's much more fast for you to do it than if you simply have to use the touchpad or the menu here, which is the folding. So for the imports and for each method of your code, for example here, IntelliJ automatically folds or automatically collapses the methods or the imports. When you have many ports, it might collapse them and appear 3 points, red senses, instead of all the imports here at the beginning of the file. For example, here, all our accessor methods from the client class, they have been automatically collapsed. As you can see, we didn't create them like this. It's the collapsed form. And if you want to unfold that, or if you want to extend this folding format for each one of them, you can do that individually. Let me first do this for this first one, get ID. You can go here, code, folding, expand. Now, as you see, it has unfolded or expanded this get ID method. It doesn't make any change on the code. It's basically a simple viewing matter. And rather than using here the code folding menus for expanding or collapsing any method or importing declaration, you can click, for example, here at the set ID method, which is folded or collapse. You can click the right button, go here at folding, and also opt to expand. You could also use the shortcut Ctrl plus to expand and Ctrl minus to collapse. So if you press Ctrl plus, it expands, and if you press Ctrl minus, it collapses again. But what if you wanna expand everything or collapse everything? There's another useful shortcut. If you don't remember, you can simply go to the folding and search for it. Almost all actions have a shortcut on your keyboard. For example, to expand all and to collapse all, the shortcut would be not Ctrl plus or Ctrl minus, but Ctrl Shift plus and Ctrl Shift minus. And that's what I wanted to show you, because almost every time IntelliJ collapses the classes methods, and it would give us much work if we had, for example, with the touchpad, go here to this button and unfold or expand individually each one of the collapsed methods. So instead of this, you can simply use Ctrl+Shift+ and Ctrl+Shift-. So let me first collapse everything that can be collapsed at this class by pressing Ctrl+Shift-. So here you have, let me maximize here. So as you can see, after I use collapse all by using Ctrl+Shift-, I have collapsed both all the import declarations as all the constructors and methods of this class. And for doing the opposite, for expanding everything, which is one thing that I'm always doing, because in IntelliJ collapses I want always to see the class with all the methods, constructors and importing declarations expanded. So to expand all, you click Ctrl+Shift+. If you press only once, you will expand eventually only part of the methods. For example, here it has not expanded the imports nor the accessor methods, but if you press it again, Ctrl+Shift+, it will expand then everything. So now it has both expanded the imports as the constructors, as the accessor and other methods we had at this single class. So the folding is for what we have inside one opened class here at the editor section. Here at the structure section, at the project structure section, if you want to collapse or expand anything, you can also press Ctrl-, so it collapses. But if you press Ctrl+, it won't expand. For expanding, you use the right arrow for each folder you want to expand. The right expands, the left collapses. So we can expand or collapse using the right arrow or the left arrow. And that's basically it regarding how you can fold and unfold or collapse or expand either at the structure section here on the left or mainly at the editor section here for each class file. So having said that, now let's go to the debug subject. It's very important for you to know both how to create tests for each of your main classes as how to debug not only the normal classes, but the debug also is very useful for when you're running the tests. And for the IDE, debugging a test class is basically the same for debugging any other class, but of course the content would be different.